Hi. In this video series about LED play, and then it goes about these LEDs. It is Python versus C++. And my first intention was to do first everything in Python and then in C++. However, I think it is a nice idea to change that idea into one board being RaspberryPi1 in Python and RaspberryPi2, this side, in C++. So I am doing a step back, and I will first let one LED go on and off in C++, and then go further where I have gone so far. So that idea takes me to creating a header class for this stuff, and I first need to re-examine this one. What is the difference? How is it set up again? It's been a while, so let me see. And if you have seen my previous series of videos about the binary counter from which this code is coming it is a completely different setup. The code is well, more complicated, to put it that way, but I think I can just use this one, probably even without renaming, although I probably should better do rename it. And let me examine GPIO class.cpp as well. Yes. Here all the other methods are defined, so I can use this one as well. Which brings me to the last part I need to check out how it is used, which is the RPi binary counter. And this one I can change. I will have to change. And one of the things that I really do have to change are these inputs, the pin numbers, because GPIO 18 is of course pin 12, so I need to really change that. And then of course it is how do I put these in action, and that is something quite different. So To avoid complications, I will copy this code into GPIO LED version 2-1.cpp and then see how to go from that. GPIO-LED version 2-1.cpp. And now I can just remove what's wrong, or more appropriately say, okay, I want to put something on. If you remember, this is putting a GPIO pin off, and this sets it on. Also, if you compare this, time sleep is 2 seconds, which is in Python, of course, while this is 1 second, or let me put it different. This is 10 seconds in C++. So that's a completely different setup. And I won't have them interact just now, but keep them to each other sides. So the nearest LEDs here, and those are this one and this one, and let me see, this one are the RPi2 side, and those will run C++. So I will first need to check again which GPIO numbers these ports are, and then I can go on and change some of the code. So the first lines that I have to change are these 3 couples, and the point is that here I have to instantiate the GPIO pins, and instantiate means that you make from a new one, from a class, a new unit. Not very accurate, but close as I can explain. And this needs from 2 to 6. So 18. I will put first the output pins and then the input pins. So 18 will be 7. Oops. No, I go wrong. It is pin 7, which is GPIO 4. And which is pin 7. This one is 18. Which is pin 12. a simple copy. Then we get 5, which is pin 29. Once again a copy. Now we get the input ports. The first one is 17. Which is pin 11. Next one is 23. Which is pin 16. And the last one is 6. Which happens to be pin 31. And now for the export, I have to change this as well. So while 18 already is there, I have to make 4. And then 5. And that goes for 17, 23 and 6 as well. And here it gets interesting, because here I define them for out or in. So my first output is 7. So this is 7. The next output port is 12. The next output port is 29. And then we get the input ports. Let me add them in one. And this is uh, 17. And here I go wrong again, because I need to, this is 4, this is 18. Pin 29 is GPIO 5. This is better. Then the input ports 17 and 23. And last is 6. And then of course I have to keep in mind that these are 3 input ports. And now they are all set. Let me first save them. So from now I can actually set them to go on or off. Here I put the first one, but this is the first one I've defined as 7, which is GPIO 4, which I set to 1. I have to let it sleep for 2 seconds. So I I've deleted one too many. So this is 2 seconds if I'm correct. Then once again 4. This one can go out, and that is one LED from the GPIO2 side, so that will be this LED, and the rest one I will comment out for now. This I have to change as well yet, so I should not forget to do that. If Ctrl+C is pressed, then setting values to 0, which is now GPIO4, sync to 0, and the rest can for now be commented out. Then this has to be 4 as well, of course. Also 4. Comment out and comment out. That is it for now. So what I can do now is compile everything. First write. No, I have to go here, because this is the serial terminal session using Minicom, and this is indicating serial. And as you can see, I'm using Raspbian GNU Linux 8, and this being the kernel. But let's concentrate on this one. And here this is quite important, because I have to change this and use this one, as this is the control where all the different actions are defined. So this is GPIO LED version 2-1, and of course I have to do that here as well. .cpp. So let's see what happens. No error, that's a good sign. So let's first look here. And it doesn't do a thing, which is quite surprising. Ctrl+C does work, but as far as I can tell, nothing happens. Let's see again. Does it do anything? I have to check something in the code. What happens? This is going to 0 for 10 seconds, so let me change this to 2 as well and check again. And now the unfortunate thing is that it isn't very good visible on cam, but when I look directly at it, it does work. So maybe if I put my hand behind it, you still can't see, but I can see that it works. So this is very unfortunate that I can't show you somehow. Let's see. Can you look at it this way? Yes, now you can see it. So this is proof that the code works. 2 seconds on, 2 seconds off in C++. So now it is time to put the second LED to work, and that is on 12, pin 12, which is GPIO 18. And that is of course more of the same. The question is though, since this second LED is less bright, will that have consequences for the camera result? We'll see. So I have changed this part of the code to be suitable for GPIO pin 18, which is GPIO 18. So pin 12 is GPIO 18, and of course I had to adapt this Ctrl+C pressed code as well to accommodate pin 7 and pin 12. So let's compile. Oops, and that was not good. That was not good at all. Now I can save one thing. You really want to write to it? Yes. And that is the advantage that I still was in the code. So now I can trace back my GCC code that I should have. Accidents happen now and then. Okay, so G++, GPIO, LED, C++, GPIO, class CPP, and then this should be the code again, or the compilation again. And now something goes very wrong. Let's see. And this indeed is the code. So the question is, where do I go wrong? If I do go wrong anywhere, I'm very curious about this. Okay, let me find back where I originally compiled anything. That is this one. So now I go forward again. And that is really actually this piece of code. So there's no problem there. I might be doing something wrong here, so let's examine. And it says in function main, but I can't find anything wrong at first sight. Let me, for checking out, see if anything is alright, and I see that everything is alright. Set val to 1, set val to 0, and that is exactly what should happen. This also 4 and 18, 4 and 18, 4 and 18 again. So what did I do? I'm going to do it all over again. C++, GPIO. This is what I want to compile. GPIO class.cpp minus IO. That is probably the problem what I did wrong. GPIO hyphen or minus actually. This should be alright. I forgot the minus O. See, that is the point. So now let's concentrate on this second LED. Will it work or won't it? Once again, it's hard to see on camera, but it is quite clear to see on on naked eye, the second LED doesn't show anything, not even to the naked eye. So that is unfortunate, which really does mean that I have to replace that LED, and I have to find something to replace it with. So let's go find something. And with replacement LED, which is unfortunately in this way not visible, but when I turn it to the camera, you can see it is burning. So that is quite nice. So that those are two LEDs on the RPi2 side that are working. Remains this LED, and let me check if it's working by turning it around. You never know. I have been wrong before, and for this I have to adjust the code first, but since for now it is only the first two LEDs. And for the second one, third one that is, I will copy these codes, or these lines anyway, put them here. Nope, that's wrong. That should be this one. And then I have to change 18 into 5, which goes for pin 29. And these values are all right. This becomes 5, and of course I have to do here a change as well to 5. And here 2 lines. And this should make the third LED work. Compiling. And now I have to make sure that this is alright. Let's see if this works. First LED by eyesight, second, and the third is doing nothing at all. So I do have to replace the second LED, and I have to find thing. So let's once again go look for a replacement. Unfortunately, I could not find a replacement LED for the third LED. I did correct the code a little bit because I forgot to copy the last 2 seconds sleep, and while everything kind of works, I decided to put the Python side of the code on the Raspberry Pi 1 back into the same action, so without the inputs, with 2 seconds sleep. And let's see what result that has when looking from above. So it's time for the camera. So when looking from above, you can clearly see that the LEDs from the Python side are working fast, and this is the C++ side with this LED not working. But what you can also notice, and that is quite odd, is that while in both Python and C++ the burning time is set to 2 seconds, the Python side goes much faster than the C++ side. So apparently 2 seconds are not equal on either Python or on the Python 1 versus Python 2. Raspberry Pi 1 versus 2. And to be clear, this is Python on Raspberry Pi 1 and this is C++ on Raspberry Pi 2. So while you can see that all these LEDs are working, well, the most left one isn't, but for the rest the code works. And I should have a look into the timing, because although the 2 seconds are quite clear, as you could have seen in the code, there's a distinct difference. Anyway, for this time it is a nice experiment to get it working, and certainly to be continued with reading in and reading out. So to be continued.